Let's talk about Langchain. Langchain is an open framework that makes it easier to build applications powered by large language models or LLMs. Think of it as a bridge that connects language models with external data, tools, and workflows to create more powerful and useful AI applications. So the key idea behind Langchain is integration, right? So instead of treating a language model as a black box, Langchain provides building blocks to connect the model with memory, database, APIs, and even decision-making logic. This allows us to build end-to-end AI applications instead of just getting one-off response from LLM. Now let's walk through this diagram that you see here that highlights the main components, right, of Langchain. Memory management. This allows applications to remember context across conversations instead of starting from scratch every time. Langchain helps retain each interaction, right? So responses are more personalized and more coherent. Now, coming to vector databases, so many of us would know what vectors are, right? So these are specialized databases that store embeddings, which are numerical representations of text. They enable semantic searches, retrievals, making it possible for the model to process relevant information. Coming to prompts, so prompts are the key for any AI application that will be built in plain LLMs or through Langchain. So Langchain brings in a more defined, structured way of managing these prompts efficiently, right? So prompts are defined as instructions which we give to LLM, and Langchain provides reusable templates. We call them as prompt templates to go on and make these prompts reusable instead of reinventing the wheel every time. Agents, that's the keyword today, right? So agents are LLMs that can make decisions about which tools or actions to use instead of just answering questions. An agent can decide and orchestrate your query to a different database, to an API, run a computational response before providing the actual response. Coming to chains, so chains is the key or coherent or the main core feature of Langchain, right? So chains link multiple components together in a single workflow. For example, you might have a user question, you might have data from database, you need to feed them together into a LLM using a prompt. So instead of doing all these sequentially in different steps, you can build them in a single chain, and Langchain is going to use that to perform your action. And coming to models, so that's the core again. Langchain can work with any different LLM, it's agnostic. You can use OpenAI, Azure, Anthropic, Cohere, any LLM of your choice, right? So it doesn't lock you to one single provider. So when you put all these different pieces together, right, models, memory, database, prompts, agents, and chains, you get a flexible framework for building advanced AI-powered applications, whether it's a chatbot, a knowledge assistant, or a multi-step reasoning system. So Langchain helps you design it more systematically, more properly, with better efficiency. In short, Langchain is not just about calling an LLM, it's about orchestrating multiple tools and components around the LLM to build real world applications that are smarter, more reliable, and more scalable. And that's what makes Langchain such an important framework in the AI developer ecosystem today. Let's move on to the next slide, right? So let's look at how Langchain works. So how does it actually perform actions? So we've taken a simple example here, which is common in most of the use cases, or one of the most highly utilized use cases, right? So now that we saw what Langchain is, this is how exactly it works, right? So the core idea is to make information from documents and external data sources, bring it all together, provide it to LLM in a meaningful way, and this slide is explaining that workflow, right? So let's start with the input. So that's where you see those PDFs, right? So imagine you have a set of documents there. These could be research papers, company records, policy documents, anything, right? So directly feeding them into a LLM is not always efficient, right? Because the documents can be long, they can be unstructured, and so on. So the first step is to chunk that particular information, right? So that's where the process of chunking comes in. So each PDF is broken down into smaller chunks of text, that is smaller pieces of information, right? This helps the model to process information in manageable pieces. Instead of overwhelming it with hundreds of pages, you break it down and provide it smaller pieces, smaller chunks of information to process. Next, let's get to the embeddings. So each chunk is converted into something called as an embedding. Embedding is basically a numerical representation of that particular text. It's like translating your whole series of text into numbers, right? So it captures its meaning. The steps become crucial because it allows the system to compare and search through the text-based or meaning rather than just the keywords, right? So it gets that semantic comparison in between, so that if you have two different uh, statements out there, two different text out there, it's not just a direct keyword match, rather it's the matching of the context or the meaning of those particular words. Once we have the embeddings in place with all the chunks there, right, they are stored in a vector database, which is also called as vector store with all different names, right? So this can be your Azure AI Search, Amazon Aurora, PostgreSQL, and so on, right? So there are many similar technologies. So the vector store now acts as your knowledge base out there, right? So where all these embeddings live, ready to be searched efficiently. Now, next step is when the interaction path comes in, right? So the user asks a question, for example, what is a neural network, right? So that's the example we have taken here. So just like we did with the documents, so the question is also converted into an embedding, right? So what you see out here. So using the same embedding model that we have used to chunk the text, we'll use the same model to create the embeddings of your neural network question as well, right? So instead of now just matching the context or the keyword within these chunks of documents, so now the semantic search is going to do a context matching, right, or a meaning matching of these embeddings with these particular embeddings, so that gets a better accuracy, better results out of it, right? Now the relevant chunks that are identified using the semantic search are passed on to the LLMs, so that's your ranked results, right? So there can be 100 different matching chunks from a particular document, but we want only top 20 to be utilized or top 5 to be utilized. So those relevant chunks are sent to these particular ranked results to the LLM, and the LLM uses those to provide your answer, right? So that's how the whole workflow is, and that's how we can build it in Langchain. Now, where does the modular components of Langchain come into the picture? Generation of embeddings, using prompt templates for using the prompts, then utilizing the vector stores as the memory, then utilizing your chains to build the whole particular workflow, then utilizing your structured output parsers to give it a structured output in the format that you needed, and then even using your retrievers, document loaders to get these documents in place. So all these steps relate back to one of the components that are there in Langchain. Let's move on to the next slide where we'll talk about applications of Langchain, or where all we can use it, primary areas, right? So chatbot and virtual assistants pretty much out there, so they can be designed to remember interactions, connect with external APIs and all that. So unlike traditional chatbots, now these rely more on predefined rules, right? So Langchain powered assistants are smarter, they can remember past interactions, pull in data and all that. So instead of giving a generic response, Langchain based virtual assistants could check your company's database, fetch real-time updates, and respond with more personalized information. Second is document Q&As. So that's again a very generic use case. So imagine having hundreds of different documents, hundreds of different PDFs, research papers, contracts. Now instead of manually searching through them, Langchain allows you to simply ask a question. The system retrieves the most relevant information, summarizes it, and provides you the answer, similar to the workflow we saw in the last slide. Third is a knowledge management system. So every organization struggles with scattered, fragmented knowledge, right? So some in a structured database, other in unstructured formats, emails, reports, wikis. So Langchain helps you unify all this by linking LLMs with both structured and unstructured data. Right? Result is an intelligent search, summarization, proactive recommendations. So let's take an example like an employee could go in and ask, what are our company's policies on remote work, right? And get a summarized answer instantly. So the model is going, or the knowledge management system is to go in, look into those policies, get the data out, summarize it in the output of your choice, and then provide it to the user with a reference to that particular policy. Fourth is workflow automation. So Langchain can chain different tasks together, like we discussed. For instance, customer support ticket could be analyzed, classified, routed, and even have a draft resolution around it, right? So all these are done automatically. Similarly, reports can be generated, CRM updates can be applied. So this reduces all the manual overload and speeds up the whole process. Then finally, data analysis and BI. So data is critical, right? And we know that data is power right now. So one of the most exciting usage of LangChain is converting your natural language into database queries. That means a manager could go in and simply ask, show me last quarter's sales by region. And LangChain could translate that into SQL, fetch the data, and even present it as charts or reports. This democratizes the data access, making powerful insights available to the technical users or non-technical users. So to summarize, LangChain enables smarter chatbots, faster document Q&As, better organizational knowledge management, automated workflows, and simplifying the whole data analysis pipeline. Now, having looked at what is Langchain, how it works, and its applications, right? So let's look at some of the key features we have been talking about, and many of these we are going to cover deep dive in detail in the subsequent videos. We'll see the hands-on implementation, code implementation of how all this works out, right? So first of all, modular architecture. So Langchain is defined to be flexible, right? So developers can plug in different components as needed, whether you want OpenAI, Anthropic, Hugging Face, all on your choice, which vector database you want to use. Langchain lets you swap and replace components without rewriting the whole entire system. So that's what makes it more modular. Second, component and chains. So individual components like prompts, retrievers can be all connected or chained together, right? So into a custom workflow, for example, a workflow might retrieve a document, summarize it, and send it to a chatbot, all within a single chain, right? So that's where your chaining comes into the process. Prompt templates. So prompts are the heart of any working LLM. So instead of rewriting your prompts every time, you can build those prompt templates, fill in with dynamic variables, and start reutilizing it or reusing it across different applications. Selectors or example selectors. So now, sometimes the best way to guide a model is to show it by examples, right? So Langchain can automatically select the most relevant examples to include in a prompt, right? So that enhances the few short prompt that you would create, and finally increasing the quality of model's responses without overwhelming it or without causing any issues around it. The next what we have is called as output parsers. So often AI responses are free form text, right? So we struggle getting it or giving it a structure, but the applications sometimes need a structure, right? So output parsers help you with that. So you can give them specific formats like JSONs, tables, SQL queries, so they can be easily integrated into the system. And using Langchain, the output is automatically modulated into that output format as the final response to you. Then indexes and retrievers. So these provide the backbone for searching and retrieving systems from large data sets. Right? So instead of scanning everything, Langchain retrieves the most relevant chunks of data, making responses faster and accurate. And chat message history. So conversations feel more natural when you have a running context behind it, right? So Langchain can store previous messages and maintain that context. This ensures that whenever an assistant is responding, it does not forget what was being discussed earlier, right? So it leads to more human-like interactions. Then document loaders and text filters. So these tools handle different types of documents, PDFs, Word files, web pages, and break all of that into manageable chunks. That makes it easier for models to process large volumes of text efficiently. And finally, agents and toolkits. Agents go beyond simple Q&As, right? We all know that by now. They can decide what tools or actions to take next. For example, an agent could query a database, call an external API, or perform calculations before giving you an answer. This turns a chatbot into a true decision making assistant out there, right? So these are the key features that we have around the Langchain system. Langchain offers modular building blocks. As we saw, all of these features make it possible to go beyond a simple LLM to more sophisticated applications that remember context, retrieve information, and does all that is needed in a real world system. And make sure to view all those follow-up videos. We'll deep dive into these technically, see how they get implemented, and that will make or highlight how important these implementations are. Now, before we wrap up, let's look at one final thing. That's the whole Langchain ecosystem. So Langchain is not just about what we saw, uh, in the slides a minute back, right? So it's more around a whole ecosystem now. So this is the architecture or the wider, broader Langchain ecosystem that we have in place today. From architecture perspective, we have Langchain and LangGraph. So that's the foundation of the architecture layer. Langchain is the core framework that provides the building block, whereas LangGraph is more structured orchestration, right? So instead of just chaining steps, LangGraph lets you build complex workflows where AI can make decisions, loop back. So it's more of the multi-agentic systems what we are looking at today. Then components talk about integrations. So on top of that, we have that particular layer. So Langchain is designed to connect with external tools, vector databases, APIs, and all those that we saw in the previous slides. These integrations are open source, which makes the framework flexible and adaptable across different use cases. Then deployment platform. So although we can have different deployment models for Langchain applications, if you're going to Azure, you can use an AKS based structure, but then Langchain also provides its own LangGraph platform, right? So if you built your application and you need to deploy it, you don't have a readily available platform, you can use LangGraph as a platform, right? And this comes in as a commercial offering, so that can be utilized there. And to the far right, you see Langchain, Langsmith, right? So that's for observability, where you can go in, do debugging, use Playground for trying out features, checking things out, use prompt templates, prompt management to manage all your different prompt templates, and everything around observability and operations towards in Langsmith. Right? So that's how the whole ecosystem is covered out with respect to AI applications within Langchain. So this was a brief overview of what Langchain is about, what are the different things in it, a very broader perspective. In the subsequent videos, we'll deep dive into all of those. So make sure to subscribe, like, and keep following, right? So there'll be more interesting content that is coming up. We'll make sure we get deep dive into all these use cases and try and understand them in more details. Thank you.